This is Bob Duchesne's Wild Maine. The new San Andreas movie is out, and it's time somebody asked the question, hey, what about us?
The earth will literally crack open, and you will feel it on the East Coast.
This is Sports Radio 92.9 The Ticket, and since the Red Sox have already been mathematically eliminated, this is the most exciting hour of the broadcast week. Bob Duchesne's Wild Maine. A new disaster movie hit the big screen a couple of weeks ago, starring Dwayne Johnson, The Rock, as a chopper pilot in the middle of a massive California earthquake who has to save his daughter from some really expensive special effects. So I started to wonder, what makes California so special? Maine has earthquakes. What could happen here? So I went over to the Maine Geological Survey and sat at the office of Bob Marvinney, the Maine state geologist. It turns out there's a fault line in Maine that is nearly as long as the San Andreas Fault. Stand by or lie down under a desk. Bob Duchesne's Wild Maine is brought to you by Hammond Lumber, Dysarts, EBS, Doors Equipment, and Napa Auto Parts. As the show begins, we're in Augusta. Well, Bob Marvinney, welcome to Bob Duchesne's Wild Maine.
Thank you. It's great to be here.
Well, by show of hands, how many members of the listening audience even know we have a Maine Geological Survey?
I hope there's some. I hope there's a lot of hands out there.
Yeah, I think nobody really knows what you do. I have some inkling, but even I couldn't describe everything that the Maine Geological Survey has its hands on.
Well, so people, when they think of the Geological Survey, they immediately think about rocks. And
yeah.
Sure, we do map the distribution of different rock types. And that's important because for a number of reasons. One is that there are minerals in rocks, whether it's metallic minerals or gemstones. I mean, the gemstones that everybody likes to see, that people make jewelry out of, that's all out of the rocks of Maine. We cross over into our groundwater program because the rocks, most people have their well drilled into rocks, and so the quality of the water is directly impacted by the rocks that's in contact with the water.
The geology.
So, yeah, the geology.
Right.
So we're mapping the geology, mapping the rocks. We map the glacial deposits that are important sources of aggregate. They're important groundwater aquifers. We have a groundwater program to investigate in more detail water resources, groundwater resources in the state, where they're being used in great quantity, where there's a need to be a little bit closer on how they're managed and those kinds of things. And then we have a coastal geology program that looks at coastal erosion, sea level rise, and those kinds of things, and the interaction of humans on the coastline, which is really important. So trying to provide the science that's the backup for policy discussions around how we should interact in those environments.
When I see a lot of the maps produced by the office, I realize just how well mapped the state is. We kind of know where everything is.
Well, we're doing fairly well. I mean, we have maps that cover the entire state at a small scale. So one map fits on a wall and covers the whole state. But we like to get down to a more detailed scale where you can use it for real planning and real project work rather than just kind of the generalities. So we've done a fair amount of that, but there's still actually quite a bit of populated area that hasn't been mapped in a lot of detail. So we constantly are working away at that, trying to improve our knowledge of the bedrock and superficial resources.
Yeah, some of the mineral mining we've done over the years in terms of the stones, tourmaline, for instance, is actually pretty impressive. It's been a long tradition, and I know in my household case, if I do anything wrong, I'm supposed to buy my wife tourmaline. So if you can tell me where to go find it on my own, I can save a lot of money.
Yeah. Well, the tourmaline district is mostly the western Maine mountains, and there's a lot of great localities there, and I'm certain there are a lot of undiscovered resources too. It's hard to find those. You know, you can find the pegmatite deposits, but they don't always have, and those are the granite-like rocks that have really large crystals in them, but they don't always have really interesting things like tourmaline or beryl. So it takes a lot of just digging around to find them.
Yeah, a lot of work and not that much reward.
Yeah, right. Yeah.
I mean, we talked about a lot of your responsibilities, and some of that includes coastal changes. from big storms, rising sea levels, all
Right.
that stuff. You've got your fingerprints on that.
We work on we map every summer. We go and look at the beaches in southern Maine and looked at the amount of dry beach there is between the vegetated dune system and the mean low water, just to get an idea how the beaches are responding.
Mm-hmm.
We have a volunteer profiling program where volunteers go out monthly and measure along fixed profiles the nature of the beach system, and we can see dramatic changes over the course of a year, which is kind of the natural cycle. But then long term, most of the beaches are facing problems because there are increased storms. We are dealing with sea level rise, which is a very real situation in our coast, and so we have to look at what those trends are and begin to figure out how to deal with it.
Yeah, Popham Beach State Park. If I remember right, it was Popham or Reed, but I think it was Popham.
Popham
Had a huge change.
Yeah,
for a while.
and that's really dramatic. It's the Morse River where it flows out into the ocean, and the mouth of that river just wanders. But everybody was surprised that it took out forests that had been there for 100 years.
Yeah,
and we had worked with Parks and Lands to identify where to put their new bathhouse, and it was originally 300 feet from the shoreline, and now it's the water's practically lapping up at the doors. So it was startling to everybody, but it's a great learning experience to learn how dynamic those types of environments can be, and so we continue to look at that on a regular basis.
And the flip side was a lot of sand was removed, revealing forests that were there thousands of years ago.
Oh yeah, right. We found some very interesting materials in that whole process.
Mm-hmm. Groundwater. We have one of the best groundwater resources in the world.
We have very good groundwater, and we have abundant groundwater. It's not to say that we shouldn't be focused on how best to regulate large extractions or manage multiple uses, but I think with the laws we have in place and with some careful discussions, conversations with all participants, we can find ways to accommodate all the uses without undue environmental impacts.
Well, we're anal protected, really, when it comes to protecting our groundwater, because it means a lot to us.
Well,
we're
it does.
Proud of
it does. It's huge. It's not only it's the people of Maine individually rely on groundwater to a large extent for their domestic water, and so we have to be very cognizant of that. Plus, the reason our rivers and streams continue to flow, even though it's been so dry, is because it's groundwater flowing out back into the surface water system.
Yeah, in fact, if you have been west and you can compare us to the west, their streams can just go dry in summer.
Absolutely.
Ours don't.
Absolutely, right.
Yeah, so there's a lot of motion underground that we're all aware of.
Right.
There's a lot of arsenic in some of that. I mean, you hear about drinking wells, and maybe up to 10% maybe don't meet standards.
Actually, it's probably more than 10% statewide, and we've looked at that on numerous occasions. And we just recommend that everybody have their well tested. Private wells, there's no regulations that say you need to test your well, but we recommend that everybody does so. We found there's probably more than 10%. It could be closer to 20% of the wells statewide have arsenic above the 10 parts per billion that a drinking water supply would have to meet. And what your neighbor's well gets is not doesn't say anything about what your well might be. We've seen wells side by side separated by 100 feet. One has 100 parts per billion, the other has 0.
Oh, wow.
So you really need to do every well needs to be tested.
Am I safe if I just bathe with it and otherwise drink beer?
Sure. Yeah, the bathing part is probably not an issue. It's really direct consumption that we worry about.
My guest is state geologist Bob Marvinney. With the new San Andreas movie out, we're looking at earthquakes in Maine. And we'll focus on earthquakes in Maine when Bob Duchesne's Wild Maine returns in a moment on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. Maine has earthquakes. So as the new San Andreas earthquake movie has just come out, it's a good excuse to sit down with state geologist Bob Marvinney and ask how many are there in Maine and how big can they get? Do we have any faults that are big enough to have names? How accurate is the movie? So let's start with that. Have you seen the movie yet, Bob?
No, I have not. It's on my list, but I usually don't go out the first weekend to see these things.
Yep. But you do monitor earthquakes, and you have a good history of what the earthquake situation has been in the state of Maine. Any general observations before I quiz you more deeply on it?
So in Maine, we do have regular small earthquakes. There's in terms of a magnitude 1 or 2, there's probably a dozen of those every year. Most people don't feel them unless you're sitting right over what we call the epicenter, right above where the earthquake happens. Most people won't feel it. Our instruments can record it, though, so we've got a pretty good track record of what goes on out there. And we might have a magnitude 3, which a lot of people will feel once a year. And then larger earthquakes, many more years between.
Yeah, okay. I mean, every state has its own unique geology, but when you look at Maine, our geological history is really fascinating because you've got the glacial period, which has had major impacts. We obviously had our own earlier rock formation periods. We had the implications of what happened when the continents separated and drifted apart.
Right.
And that all happens right here.
It does, yeah, and that's what our geologists do, along with the colleagues at the universities and other researchers. We have pieced together the geologic history, and in Maine it goes back at least 700 million years that we know of in terms of, and it's involved in that whole concept of plates moving around on the surface of the earth and colliding, and pieces being stuck between continents and continents then dividing, and we can read a lot of that history in our rocks, and it's pretty fascinating.
It's fascinating just to walk around the landscape or drive around, especially like blueberry barrens, where you can actually see it without the trees on it, and you'll see well-drained soil left by a glacier, and then a mud deposit with an underlaying lens of clay underneath when that was under sea level.
That's right. One of the interesting implications of our last glacial episode was that the weight of the ice was tremendous. You can imagine 1 or 2 miles of ice where we're sitting in Augusta, and that ice weighed down the crust of the earth. The ice melted in an instant relative to the ability of the crust to respond, and so the crust was lower, and the sea actually invaded over a lot of southern and coastal Maine, and up the rivers, up the Penobscot, all the way up to Medway was marine environment, which is pretty fascinating. So there's marine mud in all those places.
Yep, there's a favorite place of mine, the Blueberry Barrens in Columbia Falls, and you probably know it, where you can see the beach of 10,000 years ago.
Right,
and it looks like a dune. It's covered in blueberries, but
so the land rebounded, and now we're dealing with a situation where the sea level rise because of melting glaciers, etc., is slowly catching up and is overtaking and causing sea level to rise even more.
Well, you started into it about why we have earthquakes in the first place, and you talk about plates moving. So, what is a tectonic plate?
So the crust of the earth, the geologists have determined over many years, geologists, seismologists, and everybody in the broad earth science community have looked at the crust of the earth for many decades and have determined fairly well that it's broken up into major plates. So it's not just one big crust of the earth, it's all plates, and they're mobile. They actually move on the mantle. So the mantle is the material below the crust, and it's flexible in some ways, and the plates actually move around. And when they collide, that's when mountains are built, when volcanoes occur, and when earthquakes occur. And the plates are still moving. Right now, let me go back. So I said 700 million years ago. This was an active place 700 million years ago. We had mountains forming. We had volcanoes. It was a very active earthquake area. The continents collided probably the last time around 400 million years ago, and then 200 million years ago have been separating. And so right now, even though we sit at the edge of the continent, we're in Maine, the ocean's just to the east, we are actually in the middle of the plate that we're on, because that plate extends all the way from California in the west all the way out to the middle of the Atlantic Ocean.
That's one plate?
That's one plate.
Oh, wow. I didn't realize they were that
big. That's the North American plate. And California is right on the edge, So it's interacting. There's a lot of interaction between the North American plate and the Pacific plate, and that's what causes all the earthquakes there.
Mm-hmm.
We still have earthquakes here, even though we're, as I said, we're in the middle of the plate, because the plates are still moving. We're riding about a centimeter a year towards the west,
Mm-hmm.
and that motion doesn't all happen smoothly over this enormous plate of North America. It happens in little jerks and starts,
Right.
and that's what our earthquakes represent. Those little jerks of the plate moving, and it moves here, and then it has to move somewhere else to catch up, and that's what those little earthquakes, and that's mostly what we have throughout Maine and New England and the Northeast in general. There's a few hot spots related to old faults and actually old meteorite impact structures in the Northeast in Canada.
Oh, I had no idea that
Yeah,
meteorites had
yeah.
anything to do with this.
Yep, and so some of the active seismicity on the St. Lawrence Seaway is because of an old meteorite impact. And it's still just jostling. It's all tied into the current motions, but that piece of the crust happens to be pretty broken up from this impact. So it moves a little bit more readily than
So
the
a
rest.
solid hit will break up the plate a little bit.
It could.
Okay,
Yep,
yeah.
yep.
So at one point, Maine and Europe were joined.
That's right. From about 400 to 200 million years ago, we were one big
Right.
happy continent. We called it Pangea, all Earth.
Now, are they on a separate plate and we just moved apart, or did the plate break and we moved apart?
Well, it broke and not quite where it joined up. So we can look and we can find old, what we call sutures, where two plates came together, and the actual zone where they came together is preserved, and then the new break happened somewhere else. So we can actually look in places like Newfoundland, and we can see this is probably where those continents came together, and then it broke a little bit farther to the east, and now the Eurasian continent it's a separate plate, and it's across the Atlantic, across that North Atlantic ridge, which is the dividing line. Iceland sits right on that. That's why it's active volcanically. That it's actually being pulled apart.
Yeah.
And if you ever go there, you can go to their national park, their Thigvallir National Park, and you can see these great features that represent the continents just being pulled apart.
Wow. Bob Marvinney is the Maine State Geologist, and we're talking about earthquakes in Maine, some of which are caused because tectonic plates are moving. How fast? How far? If there is one thing more dangerous than an earthquake, it's me doing math. I've been entering my guesses into a spreadsheet about how fast Europe is moving away from the U.S., and we'll see in a moment if I came close. Where else are you going to get this on the radio? It's Bob Duchesne's Wild Maine on Sports Radio 92.9 The Ticket. This is Bob Duchesne's Wild Maine. Saturday mornings at 9, Sunday mornings at 8 on Sports Radio 92.9 The Ticket. The new San Andreas movie is out, starring Dwayne Johnson, The Rock, as a chopper pilot who tries to save his daughter from the big one, the mother of all California earthquakes. In Maine, the guy who knows the most about earthquakes is state geologist Bob Marvinney. We're in his office talking right now about earthquakes and how fast the continents are separating. I was trying to do the math on this. I actually sat down with a spreadsheet and say, let's see. It's about 200 million years ago we started to pull apart a little bit. We're probably about 2,800 miles away from Ireland. That means we're moving at about an inch a year. Does that sound right?
That's and that's the way we do it. We can be a little bit more sophisticated because through various exploration efforts, geologists have been able to date the ages of the ocean basin and can see that the ocean basins are oldest near the continents and they're youngest at those mid-ocean ridges, like where Iceland sits. And so it's a beautiful mirror image on both sides of that ridge. We can see the younger crust right at the ridge, and it gets successively older each way you go, either to the east or the west from the ridge. So, and the rates are about, a centimeter to an inch a year is about right.
But it's in fits and starts, and that's why you get the
right.
earthquake. So
That's right.
we have satellite technology, GPS. Can we actually see the movement? Is it that precise these days?
Actually, it is close to in some of the places where the motions are faster than we have here in the Pacific Northwest and some other really active areas. It can almost be measured instantaneously, and certainly there's a dense network of GPS base stations in California and other active areas that look at. A lot of times the ground actually moves before an earthquake, or stretches, and then an earthquake makes a big jump, and you can actually see the ground deforming through the GPS and through the satellites, looking at the landscape. Yeah.
Wow. At that point, do you up your insurance?
Well, if you lived in California, you definitely want to be sure you have insurance.
Yeah. Are we actually moving still further apart from Europe, or is there a motion to come back together again? Or?
Well, interestingly, I've read some reports that suggest that a subduction zone, which is where the oceanic crust begins to get consumed, and that a new one may be forming in off the coast of Portugal. So that would suggest that maybe we've opened as far as we're going to go, and maybe it's going to start closing. But we're not going to be around to see if that's going to happen or not.
Right. Now, the San Andreas Fault is famous. Do we have any faults that are famous enough to have their own names in this state?
Well, we do. We have named faults, and the most notable one is what we call the Norumbega Fault, and it's in southern coastal Maine, and it actually extends from Kittery all the way, and it extends all the way up across the state, all the way up to Calais. And we like to look at it as a ancient analog to the modern day San Andreas. It's about the same length. It had this similar kind of motion. The San Andreas, the plates are moving side to side. They're not, one isn't plunging other. They're not head-on butting contact. It's a side-by-side motion. North America's sliding past the Pacific plate. It's
like having two 2x4s side by side, and you slide them against each other. Right.
And so this Norumbega Fault was that same style of fault. It was active 400 million years ago. It's no longer active. We show it on maps, and people say, "Oh, well, here's a fault. This must be where our earthquakes are happening." No, it's not. That was, if you were here 400 million years ago, that would have been the place to look for earthquakes. But we like to say, one of the things we like to say is that we are actually looking at that fault, the Norumbega, at crustal depths that you can't even drill to in California.
Really?
Yep, because we've had, so 400 million years ago our Appalachian Mountains formed, and since then it's mostly been erosion affecting the landscape, and we've removed probably 10 or 15,000 feet of material that used to be the mountains of the Appalachians here, and so we are actually looking at mid-crust levels. That's why we can walk on granite here. Well, granite cools at depth, at several miles depth. When we have granite at the surface, it means there was this molten magma cooled at depth and formed solid granite, and then we had millennia of erosion that exposed it at the surface. So we are looking at very deep crustal levels and looking at the zone where we think the processes probably initiate earthquakes now in California on the San Andreas. So
because we can look deeper now because we are where it was.
So we're encouraging the California geologists to come here and look at our rocks to understand what's going on at depth in California where they can't see it.
Earthquake tourism, that has potential.
Well, yeah, I think so.
Well, if you had the plates going side by side, as it is in the San Andreas Fault in Norumbega, you also have plates colliding, which is what's pushing up mountains so that they're impacting
That's right.
head-on?
So a kind of a head-on collision causes the ends of those plates to crumple and in so doing push up large mountains. And that's the Himalayas right now. The subcontinent of India is just continuing to drive north into Asia and push those mountains higher. And one of the interesting things is that the very top of Mount Everest is marine limestone.
Really?
So, yeah. I mean, it's been thrown up
No,
28,000
you're
feet
kidding.
above sea level. Yeah, no.
Well,
right.
I've been to Newfoundland and witnessed the Gross Moor National Park there,
Right.
and you get to see where the crust was pushed. I mean, really, wasn't it even mantle pushed up onto the crust?
Well, that's right. It's actual mantle material. So as that collision happened, as the former Atlantic Ocean closed in that head-on collision, it sliced off part of the crust all the way into the mantle and threw that up on top of the land, and that's that really unusual landscape in Gross Moor, Table Mountain and other areas there that have very unusual rocks. I mean, it's mantle rocks. You don't get them at the surface very often. And very unusual vegetation because of the unusual chemistry of those rocks.
Yeah, the unusual chemistry that doesn't normally let plants grow.
No, that's right.
It's dangerous
basically
stuff.
no calcium in it.
Yeah.
No calcium.
Mm-hmm.
Yep.
Compare us then to the Pacific Rim, which is even more geologically active, I think, than California.
Right. So we call that the Ring of Fire, the famous Ring of Fire, and it's just that around that plate. So the Pacific plate, the Pacific Ocean is a plate unto itself. It's got its own plate. As opposed to North America, we grabbed half of the Atlantic Ocean,
and we're not giving it back.
Right.
By the way.
Right. And so that plate is entirely ringed by volcanoes, mountains, and earthquake active areas. So the Aleutian Islands in Alaska, that's where part of the Pacific plate is plunging under another section of plate and causing those volcanoes to occur and erupt. Same thing in Japan, in the Philippines, in parts of New Zealand. It's the same thing. In South America, that Pacific plate is being forced beneath the continent of South America, and that pushes up the Andes Mountains and all the volcanoes that are part of that mountain system, and all the earthquake activity that goes with it.
So it's really around the edges of the plates where all
That's
the
right.
big activities
Around the
happen.
edges, although we're in the middle of the plate, we were not immune. We had a few summers ago that large earthquake in Virginia, Mineral, Virginia. It was a 5.8. That's the same setting as we're in. It's in the middle of the plate, but so we can get those kinds of damaging earthquakes. They're just very far between. It's hard to get a really large one, but we can get damaging earthquakes.
On the occasion of the new San Andreas movie coming out, I'm in the office of Bob Marvinney, Maine state geologist, and we're talking about whether a big earthquake is possible here, and really whether that big one is possible there. Spoiler alert, it isn't. You've heard of the Richter scale, but do you know what it really means? I'm sorry, but it's another math question. And it's up next as Bob Duchesne's Wild Maine continues on Sports Radio 92.9 The Ticket. This is Sports Radio 92.9 The Ticket with Bob Duchesne's Wild Maine. Today's show is coming to you from the office of Bob Marvinney in the Maine Geological Survey. He's the state geologist, and we're reacting to the new San Andreas movie that just came out. Maine has earthquakes. California has never had one bigger than 8 on the Richter scale. Maine has had a few that hit about 4. Does that mean ours are only half as bad? Nope. Explain the Richter scale, because if I remember right, that's logarithmic.
That's a logarithmic scale. That's right. So in terms of from a magnitude 1 to a 2, it's actually measured in terms of the magnitude of the waves. The rippling of the earth is 10 times as much at a 2 than it is at a 1. The amount of energy released is actually almost 30 times. So, so for each step up in the Richter scale from 3 to a 4, those waves increase 10 times. So it's a logarithmic scale, and a tremendous greater amount of energy is released in each one of those steps.
So we're capable of having a 2 to 3 or 4 on the Richter scale earthquake in this state, and the difference between a 3 and a 4 is tenfold.
That's right.
Oh.
Yep.
Wow.
So it's huge, and so to release the amount of energy that's released in a magnitude 4 earthquake with multiple magnitude 3s, you'd have to have about 30 of those magnitude 3 earthquakes to release that much energy. And it's the same thing up the scale. So, there's a big difference between a 7 and an 8, even in California. That's a big difference.
Tenfold.
Yeah.
Well, is there an earthquake, by definition, they can go up to 10?
I think 10 is physically, based on physics, as high as it could possibly go. I think it may be a shade below that. I think the largest we've ever measured around the Earth is 9.2 or 3. That was down in Chile quite a few years ago.
So there's no way to turn it all the way up to 11.
No, I don't think so. I know I read somewhere that, like a magnitude 12 would require a fault that's larger than the Earth itself. So
yeah. Oh, so Jupiter can have a big one. But,
Yeah, right.
Well, how big does a quake have to be before the normal person feels it?
I think most people a lot of people would feel a magnitude 3 wherever it occurred in the state. If, as I mentioned earlier, if you're right over a magnitude 2, you'll feel that, but it wouldn't be felt very far. We had in 2012, October 2012, we had a magnitude 4 in southern Maine, and that was felt over all of New England and into Canada. So so by the time in our terrain we're up to magnitude 4, we're feeling it throughout the entire region.
Yeah, but, what would a 4 feel like? Just for relative sake, is 4 enough to spill your beer? Is it enough to break a window?
It's enough to, I think, if you were right over it, it could crack a window potentially. It would knock dishes off your shelf possibly. Most other people, it would just be a rumbling and a rattling. And I remember the October 2012 earthquake at my house, which was 50 or 60 miles from the epicenter, and I felt it rumble, and the couch shook and things in the house rumbled. And
Yep. I remember one that's somewhere around the year 2000. It was maybe 1999 or something like that. It sounded like a transformer blowing. It was a loud boom. Yeah,
and that's so there are large, what we call surface waves that actually propagate over the surface of the Earth, and they can generate a noise. And I think it's more when it interacts with human structures that the structures do the rumbling and make the noise.
Oh, okay. Well, how big an earthquake before we decide to sleep in the yard?
I think we'd have to be well over magnitude 5, probably pushing a magnitude 6 before people would be really concerned about what the damage might be.
Okay. Are there landmarks in Maine where you can actually see some of these old faults?
They're hard to see.
Yeah.
They don't form the kind of the puckered landscape that we can see in California that represents the San Andreas. Because our faults are very old,
eroded
for the most part. It takes a geologist to guide you there. Most people would walk right across these and not know that they were walking across a fault.
And could you see them from the air?
Well, we can see features that are probably the trace of a fault zone from the air or in the detailed elevation data that we have now. We call it LIDAR, where an aircraft flies over with a laser beam and measures the elevation of the Earth, very detailed. We can see a lot of geologic features in those. And we see some things that are probably faults because prominent ridges made up of a resistant rock may have been offset 400 million years ago, and so we see a ridge that goes somewhere, then it's offset and it takes up again at another spot. So we can see those kinds of things. And we can see some traces probably where the rocks are a little bit more brittle and they've been eroded a little bit more easily, so they make depressions.
How good are predictive models these days? Can you figure one's coming?
Predictive models are very poor. No, you can't really predict the time and place of an earthquake. The USGS puts a lot of effort into identifying probabilities, zones where it's probable that earthquakes might occur at a certain level within a certain time period, but it's not possible to go to an individual section of a fault and say, tomorrow this fault is going to have, this earthquake's going to happen right here.
Yeah, you can't say to somebody, now might be a good time to go visit Florida.
Right.
Okay.
Right. Yeah.
Well, we have models for what a 100-year flood looks like, a 500-year flood. We have some understanding of that. Do we have similar models for a 100-year earthquake or a 500-year earthquake?
Well, right. We have what we call recurrence intervals, and that's how long, how often earthquakes will occur on a certain fault or in a certain zone. I know there have been some of these types of studies done for Maine and New England, and something like a magnitude 6 earthquake. We have had those before. There was a 6.5 off of Cape Ann back in the 1700s. Its recurrence interval is probably anywhere from 300 to 500 years for an earthquake that large in our area. California, recurrence interval for magnitude 6 is probably on the order of a few years. So there's that level of understanding is out there, and there's been enough research and been enough earthquakes too.
Right.
It takes the experience. How often do they occur? Well, that's probably what's going to happen next. Same kind of interval. So,
If an earthquake happens and the earth really gets shaking, what are we supposed to do about it? Hide in a doorway?
nope. You're supposed to drop, cover, and hold. So if you're in a building, you stay where you are, get under a desk, put your hands over the back of your head and neck, and hold on to something if you can. Hold on to the leg.
My beer.
so that the table doesn't walk away while you're laying down there underneath it. That's the best thing to do. There's usually not enough time to think about trying to get outside of a building. And then there's many ways to prepare. Just things like don't have heavy objects on tops of bookcases. Even in Maine, that's an important thing to do. Or have heavy objects above places where people sleep in beds, or where they might fall asleep on the couch watching TV. Just don't have heavy things up there. Keep those in other places. Secure, the TVs on top of large stands. Make sure they're secured so that they don't fall over. There's a lot of things that people should do like that. Have your emergency kit ready, so if the power goes out, it should be just like what you'd do for a winter storm. The same kind of preparedness.
Yeah. Our building codes, do they take earthquakes into effect at all, or do we even worry about earthquakes when we're building structures in Maine?
We do. Public structures all need to take into account the potential for earthquakes, and USGS produces some maps that show what the likelihood is for earthquakes of a certain size, and so large construction projects all have to comply with that. Anything that requires permitting will require some consideration of those that potential in the building design.
I would think a stick-built house would wiggle around a little more and be a little more forgiving than bricks.
Right. The worst kind of structure is the unreinforced masonry structures. So walls that are just made out of bricks or stone that are just mortared together, those are the most vulnerable. And the stick-built, the wooden-framed buildings give a little bit. They'll flex without, there'll be some cracks, but they'll flex without falling apart.
Bob Marvinney is my guest. He's the Maine State Geologist, and we're talking about earthquakes in Maine. The conversation is inspired by the new San Andreas disaster movie that just came out. Maine has the potential to be rattled by earthquakes, and sometimes we get just as shaky as the Red Sox bullpen. But we're not likely to get leveled by an earthquake here. But what about a big one elsewhere that sends a tidal wave, a tsunami this way? Okay, I'll ask that next. This is Bob Duchesne's Wild Maine on Sports Radio 92.9 The Ticket. Welcome back to Bob Duchesne's Wild Maine. There's a new blockbuster disaster movie out about a huge earthquake in California that forces Dwayne "The Rock" Johnson to be a hero. It's called San Andreas, and it shows a whole bunch of stuff that could never actually happen in real life, and certainly not in Maine. But what could happen in Maine? Could a tidal wave come from a quake somewhere else and rip up all our lobster traps? We read about tsunamis in other places in the world. Are we vulnerable to tsunamis? Even though we may not have that big an earthquake challenge here in Maine, is there something in Iceland that would send a wave big enough?
Yeah, the greatest potential for generating tsunami that could affect us is actually the Puerto Rican Trench. So that's a deep ocean trench on the north side of the Caribbean island of Puerto Rico, and that's an active earthquake zone. And if a major earthquake happens there, it could generate a large tsunami. We would have 6 to 8 hours of warning for that. So there have been smaller tsunami events from smaller earthquakes generated in the Northeast, so there can be small tsunamis. There's a potential for I think in the Canary Islands for a volcano that could slough off, could slump into the ocean and generate another tsunami, but that would give us considerable warning. We also have at our advantage is the Georges Bank. It's kind of like a doorstep.
Yes, it is.
The waves would have to trip over to get to us, and so that protects us to some degree as well.
In fact, anything around Puerto Rico, wouldn't Florida be a speed bump?
Oh yeah. There'd be a lot of warning and a lot of energy lost as that moves to the north.
Yeah, because as we alluded to before, earthquakes can be fairly near the surface or rather deep.
That's right, and most of ours are shallow. And actually California's vary, but most of them are shallow to intermediate. The deep earthquakes are the ones mostly around the Pacific where there's those very deep trenches. Japan, the Philippines, under South America, the western border of South America. That's where the plate is plunging down, and earthquakes can be generated several hundred several hundred miles deep.
Explain to me this. Obviously, Yellowstone National Park is really in the middle of the plate, I would think. Why is that a caldera and ready to blow up?
Yeah, that's interesting. So on several locations around the Earth, there are what we call hotspots, where down in the mantle, so thousands of miles depth in the Earth, there's just a spot where molten material is rising, and it continues to rise from that same spot for billions of years. The plates on top kind of slide over that site. So Yellowstone is sitting over one of those sites, and we can actually trace back through geologic time and see how the part of the continent between Yellowstone and the Pacific actually slid across that same hotspot over millennia. So the Craters of the Moon National Park in Idaho was once where that hotspot sat, and so all this lava came out, millions of years ago at that location. Now Yellowstone is sitting over it, and sometime millions of years from now that'll move farther to the east as the continent slides farther to the west. The other example is the Hawaiian Islands. They are sitting on a hotspot and happens to be under the big island of Hawaii, but each of the chain was sitting on that hotspot at one time and has now moved off.
Any chance that whole thing will blow? What did geologists think, really?
There'd be a lot of warning because it takes a lot of magma moving, and that would give a lot of warning. So there's nothing imminent, I don't think, for probably 1,000 years.
Okay. Well, let's deal with some of the myths or facts out there. Can an earthquake open up and swallow people?
No, that's one of the big myths. The Earth itself will not pull apart in the style we have been accustomed to seeing in movies, and swallow houses and cars. There may be landslides. That's different. A landslide may be generated by an earthquake, and that kind of looks like things being swallowed up. But the fault itself will not generate that big rift that things fall into.
Any chance that California is going to fall into the sea?
Not for quite a few millennia. No, that's not going to happen. It's going to continue. Part of it is going to continue to slide northward because it's actually riding right on the Pacific plate.
Can fracking cause earthquakes? Is there anything we do wrong?
Fracking itself, that's an interesting question. There's a lot of debate right now. The problem has been fracking, and actually conventional oil and gas production generates a lot of wastewater. And the biggest problems have been dealing with the wastewater, injecting it into the ground. And Oklahoma is dealing with that in a big way right now. They have a lot of these injection wells. So it's not actually the fracking process itself, but it's dealing with the wastewater that is a consequence of fracking, but is a consequence of conventional oil and gas development also. Those wastes have been injected into the ground in many locations. Oklahoma, it's been many decades that it's been injected into the ground, and I know, dealing with my colleagues at the Oklahoma Geological Survey, they actually think that it's just been an issue that's been developing over time, and we just happen to be at that time where so much has been injected over many decades that it's beginning to impact basically reduce the friction on some faults and allow them to move.
So at one point we could actually say, whoops.
Yes, and it's documented. There are cases around the country where we've seen that very thing happen, where you look at time when an injection was done and then when the earthquakes occur, and if you line them all up, it's very clear that the injection is causing these minor earthquakes.
Can animals predict earthquakes?
I don't think so. I don't think there's any documentation lately. I know a lot of people say, well, the dog started acting funny. It's not really predicting. They may feel something before humans do. Of course, dogs can hear higher pitches than humans can, and there may be an early part of an actual eruption, so right at the instant of erupting, that sends out some sounds that are inaudible to humans, but that other animals can hear.
And in all fairness, every dog I ever had always acted funny, and it was just coincidental.
Right.
All right. Well, I guess as a closure for the show today, why don't we both go see the movie, then we'll compare notes about what was really accurate.
Excellent. We can do that. Very good.
The new movie is San Andreas, a disaster flick about a big California earthquake that couldn't actually happen. And my guest has been Maine State geologist Bob Marvinney. Unless we get hit by a big one this week, join me next Saturday morning at 9 or Sunday morning at 8 for Bob Duchesne's Wild Maine. And remember, this show and all previous shows are archived on the web at 929theticket.com. It's brought to you by Hammond Lumber, Dysarts, EBS, Doors Equipment, and Napa Auto Parts on Sports Radio 92.9 The Ticket.